Okay, well, my name's Cody Maxwell, Fannin County Extension Agent for Agriculture and Natural Resources with Texas A&M AgriLife Extension. And if you remember back, I feel free to ask any questions at any point that you may have them. Be happy to address those. We're going to assume at the start of this webinar that you have soil tested, that you are either waiting to get your soil analysis back or you already have that back. That's at the stage of this webinar that we're in right now. If you have questions about soil testing, if you have not soil tested, I'll be happy to answer any of those questions that we can. But on this part two of the webinar here, we're going to assume that that's been done. We closed last time, and I'm going to back up just a couple of slides here. We talked about pH, and I'm going to call your attention here because we need to start here to set the stage for the presentation today. But I want to, give me just 1 second here. We've got a little laser here. I want to call your attention to this section right here. This is the pH. And so before we talk about lime, we need to talk about the pH. So you can see this third column right here that we have on our soil analysis. That's the critical limit section. That's where we want to be as far as our pH or our levels of nutrients are concerned. We back up to the pH right here, and we understand that this particular soil right here is a 5.9 pH. Our critical level that we want to be at for growing improved and hybrid Bermuda grass for grazing is a 5.8. Therefore, there is no limestone that is required for this particular soil that we're on right here. So moving ahead, pH is the measurement of the acidity in the soil. We talked about that on part one of this webinar. We talked about the things that cause soil acidity, the apparent material leaching that we can see, and then also cultural occurrences that happen within that soil that cause acidity within the soil. On this particular chart right here, we talked about the different types of grasses, the levels of pH that we want to be at for each one of those, and that brings us up to the point that we're at today. And we start with how do we adjust our pH? Well, we go back to that critical level, and if we're below a 5.8, our soil analysis is going to recommend a amount of limestone to be applied to this particular place to adjust this pH up. And we adjust that pH, we bring it up with limestone. I get asked the question many times about, well, if I'm at a 8.0 or an 8.5, how do I bring it down? We work with what we have in that situation. We don't want to get into bringing a pH down because we can eventually hurt ourselves to bringing it to a point and a level of acidity that we can't return from, a detrimental state. And so there's a lot of things, and we can refer back to that chart. There's a lot of things here in Fannin County, the North Texas area, that will grow in a alkaline soil, even moderately alkaline, slightly alkaline type soils. We can grow a lot of things in this area. Really, the only things that we can't grow whenever we get into those situations, you go back to that chart, and an annual grass, crabgrass is one that doesn't do as well in the alkaline type soils. And then you get into those fruit crops, blueberries. Blueberries, you've got to be on a really acidic type soil to grow those. But anything else that we're trying to grow here in the county, specifically our forage crops that we're talking about in this presentation, we can grow anything from about a 5.5 all the way up to about an 8. And so that's a range of adaptability within things that we're looking to grow here. When do we know exactly when to lime? We talked about that just a little bit ago, but here's some arrows that show the correlation with the pH level and then how much limestone are we having to apply. These limestone recommendations come from our soil and water testing, forage testing lab down at College Station through Texas A&M AgriLife Extension. But if you have a pH that is anything below a 5.8, within a certain range, and usually it's, from what I've seen, it's usually down to about a 5.2, 5.3. Anything from a 5.2, 5.3 up to about a 5.8 is going to recommend 1 ton of limestone. You see that there on the left-hand side that says, what's the reality, or when will I be effective? Well, we go back to that chart that I breezed through really quick, and if you need it, it's certainly available. I can email it to you. And again, this presentation will be online. But when we get into some of those grasses that like those moderately or slightly acidic type soils, you know, we kind of may alter that line just a hair if we get into some of those grasses that are more so acidic type soil liking. What's the number that I'm talking about right there? Probably about a 5.5. There's some situations where we can really look at a budget and determine, hey, what's the best thing for us to do when we get down there at about 5.3. I will tell you this, though, that we've seen in many situations when we get down to those low 5 pHs, 5.0 to a 5.3, we see more response from fertilizer. We see more response from the grass when that pH is going to be up above a 5.3. We get up about a 5.5 or better, and as you see, the critical limit here on the soil analysis recommendation is a 5.8. We see more responses to the fertilizers that are put down. And of course, we can get back to things that cause soil acidity and really dig deep into why that is because of those reasons. But we're going to see a much better response to our fertilizer when our pH is at that critical level or better. So that's the reason that we spend some time focusing on that. Getting into some of the limestone quality, and we talk about this before we get into the fertilizer recommendations, and it may not pertain to some of you. Some of you may be on an alkaline type soil, and talking limestone, talking pH doesn't mean much to you right now. Hang with us because we're going to get into some fertilizer calculation here in just a little bit that I think is really going to benefit you in terms of understanding how and why and when we apply fertilizer. But before we get there, limestone quality, not all limestone's the same. We grade or we determine the quality of the limestone based on the size of the limestone. When we get into those smaller particle sizes, we're going to call it ECCE. We'll talk about that here on another slide. But when we get into those smaller particle sizes, they are going to react and amend that, or react and raise that pH quicker than those larger particles. You see there that the particles that are larger than 0.08 of an inch in diameter don't react with the soil to change that pH. So the smaller the particle size, and it gets into the limestone quality, but the smaller the particle size, the faster we can change that pH within that soil, and the more effective that we're going to be in changing that pH as well. I said it was called the ECCE. That stands for Effective Calcium Carbonate Equivalent. Not to make you dizzy or anything, I'll try to go slow, but I'm going to go back to this slide right here. Oops, excuse me, I'm sorry about that. Let me pull out the laser pointer here, and we're going to go back. Whoops. I'm sorry. This slide right here is the one I'm trying to get on for the laser pointer. You notice right here in this area, the bottom right-hand side of the yellow and white chart there in the center, we see 100 ECCE per acre. Effective calcium carbonate equivalent is what that's referred to. And what it means is basically the degree of fineness of that limestone. So you're going to see whenever you purchase limestone or somebody purchases limestone and applies it for you, that most of the agricultural limestones that we see on the average is going to be somewhere between 50 to 70% ECCE. We noticed on soil test recommendations that we've been referring to that A lot of soil tests that we see that are in moderately or slightly acidic soils may call for 1 ton of 100% ECCE limestone. You may find some that's better than 70%, and if so, that's great. We've heard that some limestone that comes from Hugo is roughly about 67% effective calcium carbonate equivalent. So we got to get into some calculations whenever we're trying to get 1 ton of 100% ECCE limestone to neutralize that pH. So since we're working with the percentage right there, we divide 1 ton by 0.67, being 67%, and that means to capture 100% of effective calcium carbonate equivalent limestone, we've got to apply 1.49 tons to capture that 1 ton of 100%. I haven't priced limestone here recently. This calculation was from a little while back. It's probably going to be a little bit more than that. As many of you know, our input costs are on the rise right now. Commodity prices are on the rise. We'll talk about that when we get into fertilizer calculations and give you pretty close to exact numbers on that. That's how we figure, though, the effective calcium carbonate equivalent. If your effective calcium carbonate equivalents, let's just say if you were to find some, it's 75%. All we'd have to do there is do 1 ton divided by 0.75, and that means that we would have to apply 1.33 tons of limestone to capitalize on 1 ton of 100% ECCE limestone if that effective calcium carbonate equivalence was at 75%. So with that, we'll move into when to apply limestone. And if at any point in time you have questions, again, very informal here, we'll be happy to take those, but we'll also have time at the end to answer questions as well. When to apply limestone, have a plan for your grass, when the fertilization will take place, and when you're going to utilize that grass. We're right in the time frame right now of thinking about warm season perennials, even though we're utilizing cool season annual grasses right now. That's growing out there, and as many of you have probably noticed, Bermuda grass is greening up, starting to grow a little bit, actually. We'll talk about our soil temperature here in a little bit. But we're in a time frame where our cool season annual grasses, such as the ryegrass that may be growing voluntarily on your place, or if you planted cool season annual grasses or cool season legumes on your place, whether it be wheat, oats, ryegrass, cereal rye, triticale, any of the clovers, vetch you may have planted back during the fall months, we've moved into an actively growing state of those, which takes us into a utilization period. Many of you that are running cattle probably notice that they're what we call chasing green right now. They're probably still utilizing that hay that you're setting out, but they're trying to chase that green, the stuff that's coming up. So we're utilizing cool season annuals. We're planning for utilization of warm season perennials. So in terms of limestone, what we need to focus on there on when to apply limestone is what we're trying to utilize. So basically, I say all of that to say, if we're utilizing and our focus is warm season perennial grasses, we need to apply our limestone about 6 to 8 weeks prior to the actively growing state of those grasses, which means the ideal time to apply limestone for warm season perennials is during the winter months. You've probably seen lime being applied in recent years, long about January and February. Usually about the typical time that we would apply limestone around here for the most part for our warm season perennial pastures or hay meadows was the week that we had the polar vortex for Texas. Was when we were in those sub-zero temperatures, when we had frozen precipitation on the ground. That usually on a normal year is when we're going to be applying limestone, because we're thinking of our our spring green up taking place typically on average years April 15th, when those warm season grasses begin to wake up, when they start to move into an actively growing state. And so we try to get ahead of those about 6 to 8 weeks to get that limestone down. That way it has time to neutralize or help bring that pH up. We like to time it with the rain. And then in terms of trying to utilize cool season grasses, we move into more of a possibly a fall application on this limestone. And so limestone is something that I would say it's when we think of it, we don't think of it in terms exactly as we do fertilizer. Fertilizer, when we put it down, you probably saw a lot of fertilizer buggies running yesterday afternoon. I know I did, and you probably did as well. So they were applying nitrogen yesterday for the most part to try to get these cool season grasses to really take a spark from that rain that we had last time. So we're looking for quicker results when we fertilize. Limestone application is more long-term results. You know, it may take us a couple of times, a couple of applications of limestone to get that soil where we want it to be, but it's not going to be the quicker fix like fertilization is going to be. So plan your grass, plan when you're going to fertilize and when you're going to utilize. It doesn't matter if we're in a warm season perennial stage, a warm season annual stage, cool season annual stage, or what it may be. Have a plan for it. If you need to talk about it, feel free to ask us or call us ahead of time. Be happy to visit with you about that. The different types of lime that are available. The most common that you're going to see is the dry bulk limestone. And as you saw in the picture prior to this, it's applied with the fertilizer spreader. We also get asked the question times of liquid lime. It's going to be a little bit more expensive, but the advantage that you have with it is it's going to react that soil a little bit quicker, quite a bit quicker than you're going to get with the dry bulk limestone. The only thing is when we're trying to neutralize, bring up pH of a soil, a lot of times we're not looking for the quick fix on it. We're looking for the long-term effect, because anytime we go in and do things that we're talking about, like right here, forage management, we're investment's probably the best way to describe it. We're making an investment on the property. And so many times when you make an investment, you're not trying to cut corners or do things the cheap way, even though we're saying liquid's more expensive. If you're needing something done fast, by all means, you know, it'll certainly work. But if we're trying to really get this soil where we need it to be, then and you're looking for that long-term effect, then the dry bulk limestone would be your answer. Now moving into probably what a lot of you are here for, and that's the fertilizer calculation. Any questions up to this point that anybody might have? If not, we'll move into these. I'm going to show you two different links right here. Feel free to take a picture of those, write them down. I like to use Google, so probably the easiest way is Fertilizer Calculator, AgriLife Extension, or just go to our soil testing website, soiltesting.tamu.edu, and it'll get you there. I'm going to also show you how to get to our fertilizer calculator, and I'm going to show you how to use it here in just a little bit. There's also another one that's pretty good out there. It's through the Noble Research Institute. It works really well. I'm not going to use it today. I'm going to use the one from Texas A&M AgriLife Extension, but the one from the Noble Research Institute is also available for you to use. Both of these websites are public access. You don't have to have a password to get into them. You don't have to be an extension agent to get into them or work for the Noble Foundation. They're free and they're available for anyone to use. So a fertilizer. Many of you have probably noticed that there's three numbers that are associated with a blend. You know, you probably have been through the lawn and garden section at Walmart, Home Depot, Lowe's, wherever, Tractor Supply, wherever you go. And you've probably seen bag fertilizer and you've seen three numbers on there. So these numbers correlate with our nutrients. A lot of times when we get into these agriculture fertilizer blend calculations, now we're starting to see a fourth number. I don't have it in this presentation right here on this slide, but if we were to, I'll go back to that laser pointer. If we were to put another dash right here and another number, that last number would actually be sulfur. You're starting to see it come up a lot on soil tests that come out of our county in the North Texas region. So if it calls for it, we certainly want to address it. And many of our fertilizer dealers around here will address that for you. And they have sulfur to address that deficiency if you so have it. So what do these three numbers mean right here? Well, the first number is going to refer to nitrogen. The second number is going to refer to, it's going to be listed as P2O5 on your soil test recommendation chart, which is going to be your phosphate there. The third number is going to be listed as K2O. That's going to correlate with our potassium in the soil, but we're going to apply it as potash, as a fertilizer. So that's what those three numbers mean. We'll get into our soil test. I'll show you some analysis here in just a little bit. But when we're looking on the right-hand side of the column, we're going to see a lot of numbers represented there, but for the most part, we're going to see three numbers that are represented on the right-hand side of our soil analysis column. The first one being the nitrogen, second one being the phosphate, and the third one being the potash. All right, so here, this is a particular blend right here, and it'll make a little more sense once I show you a calculation here in a little bit. So this example of this blend that I have here, excuse me, I'm sorry about that. Trying to get back to that laser pointer. So this is a fertilizer blend, 22-22-4. So that means how we read that is there's 22 units of nitrogen, or the form of nitrogen that they use. There's 22 units of phosphate in the form of diammonium phosphate, and there's 4 units of K2O, which would be potash as the fertilizer. We look at them as units. We can also look at them as a percentage as well. So what these numbers mean is if we applied 100 pounds, and that's, I said if there, but we look at it as if it's a percentage. So 22%, 22%, and 4%. So if we apply 100 pounds of this fertilizer blend, then that means we're applying an actual 22 pounds of nitrogen, 22 pounds of phosphate, and 4 pounds of potash. That's what those numbers mean. We're going to blend it. This is just to set the stage for what we're about to move into. So we look at it as units and percentages. Then when we have many of you that have applied fertilizer before, you know, they may tell you, hey, apply 200 pounds of this blend, or apply 350 pounds of this blend. That's where we're setting the stage right here. That's what that means. If we were applying 200 pounds of 22-22-4, that would mean that we're getting an actual 44 pounds of nitrogen, 44 pounds of phosphate, and 8 pounds of potash going into that soil. So we're just doing math right here is basically what it looks like. Move to our next slide here. So here's the numbers as of about 2 weeks ago. I haven't checked on them this week. I'll tell you this. I updated this slide from last time I gave this, and so this slide I used it last year. This particular one right here. Last year, nitrogen was under $400 a ton. Diammonium phosphate, or the Daemonium Phosphate was right around 400 bucks per ton. Now potash is one we haven't seen change much. So what's going on right now is obviously we have fuel prices that are increasing. We have commodity prices that have been increasing since the first of the year. I don't know if any of you have priced any corn, if you've bought any feed here lately, but your feed costs have probably gone up significantly since you started feeding animals back in about December. So we've got corn planting that's going on right now. We're going to be moving into those other warm season crops, grain, sorghum, soybeans, cotton here in the near future. And so with commodity prices up, fertilizer prices have gone up as well. So here's some of the prices that we're looking at right now. Nitrogen is going to run you about $4.30 a ton. Diammonium phosphate is roughly right. It's about $6.60, but roughly running between about $650 to $700 a ton right now. And then potash is roughly running about $380 to $400 a ton right now. So you probably see these numbers and think, whoa, how in the world am I going to fertilize? Well, we'll talk about it here in a little bit on how you can actually justify these fertilizer applications. So that's to set the stage for the costs that we're moving into. So, all right, we're going to do some calculations now. So here's where we're going to start. Here's the soil test form that I'll show you. So kind of lock these numbers in your head and feel free. I mean, we're going to take as much time as we need. We will have to wrap this up by 1:30, but hopefully by 1 we can have gone through enough calculations to at least kind of make it a little understandable for doing these fertilizer calculations. Again, if you have questions on this, I don't mind. We've been calculating fertilizer blends for the last few weeks here at the office for people that call or email their soil test in. And so I don't mind helping you do this calculation as well. But I think it's really good for us as producers to understand, if nothing else, how it works and how that blend gets in our buggy and how we know what we're told to apply on there. You know, many times it seems that it happens that you go and you get a blend of fertilizer and you're told to apply 200 pounds per acre or whatever it may be. And as producers, we need to know that when we're applying 200 pounds of whatever blends in that buggy based on our soil test recommendations, we know exactly how many pounds of these nutrients we're getting per acre and what we can expect out of that. So we start here. I'll bring back the laser pointer for you. And we're going to go over here to this right-hand side. This is our fertilizer recommendation from a soil test here. This soil test has, this actual soil here has 2 parts per million of nitrates in the soil. So as you can see, it's extremely low. So critical level here in the center of the screen, to bring this up to the critical level for improved hybrid Bermuda grass in a grazing situation, it's going to take 55 pounds of nitrogen per acre. Now notice down here in the fine print, this is another area to really pay attention to. On this Bermuda grass, when I get it grazed down, when it's grazed really short, I got to come back in and apply 70 pounds of nitrogen per acre to bring it back up to the critical level here for my grazing situation. So this fine print down here gets overlooked a lot of times, but always make sure to look down below here. But for our initial fertilizer application, 55 pounds of the form of nitrogen is going to be required. We have 9 parts per million of phosphorus within the soil, so we're very low in that area. We've got to bring it up to the critical level, and to do so, it's 55 pounds to the acre to do that. Potassium. has 111 parts per million. Our critical level is 125. So to bring that up, we've got to apply 10 pounds of potash to be able to do so. So that sets the stage. So feel free to, I'm going to be taking notes and writing along as we go here. So our N is 55, P2O5 is 55, and our K2O is 10. So I'm going to stop the share right here. And I'm going to take us to another page. I notice there's a question in the chat box. I'm going to address this real quick. Yep. So if you can just send me an email at cody.maxwell@ag.tamu.edu. I will email you this slide presentation. And then also the question was asked to me, how do I access the recording? We have a YouTube channel. It's Fannin County Texas A&M AgriLife Extension. You can go to our YouTube channel and you can access all of our YouTube webinars on that, or feel free to just send me an email and I'll send you the direct link. I'm going to pull up the soil test calculator at this point. Hang with me here and I will share it just as soon as we get it pulled up. Any other questions before we move into this? I know this can get a little confusing, but hopefully we can help clear that up. I'm going to share our screen again. Here's what the fertilizer calculator looks like. As you can see up at the top, there's the link to this website that you saw that we showed just a little earlier on in the presentation. You go down here to the bottom, you can print these calculations, you can reset it. I'm going to reset it and walk you through this from the start. So this particular soil test here requires 55 pounds, and I'm typing as we go along. So this would be just as if you were doing it. We're live typing this in. 55 pounds of nitrogen, 55 pounds of P2O5, and 10 pounds of potassium. Right up here at the top, we type that in. And we'll do it for every soil test that I'm going to show you today. All right. So this next section is your first fertilizer selection. So to make that blend, it takes fertilizers to blend together to make a custom blend for your property. When you go into a fertilizer dealer, they're going to have pre-made blends there. We always recommend to make sure you do a soil test, because when you do a soil test, we can customize these fertilizer blends, what goes in your buggy specific to your soil. It's not what your neighbor has. It's not what your neighbor put down, because remember, back to February when we had the first presentation in this, every single person manages their property different. And through different management techniques makes different fertilizer customizations. So soil testing is key, and fertilizing based off of those soil test recommendations is key as well. So for this first fertilizer selection, as you saw, many of our fertilizer dealers are going to use either urea or ammonium nitrate is their nitrogen source. Many of them that you're going to see is urea is probably going to be a little bit more common. So the makeup of urea is 46-0-0. So 100 pounds of urea has 46 pounds of nitrogen in it. So these are drop-down boxes. I'm using urea, so 46-0-0. What did we say the price was? I believe it's $4.30 back on that slide. $430 to the ton. Now we move down to this second fertilizer blend, which is going to be our phosphate. And your phosphate is going to come in the form of diammonium phosphate. And the actual blend of that is 18-46-0. Price per ton, 660. Potash, the blend for that is, or the formulation for potash is 0-0-60. So we go here to our K2O, we do 0-0-60, and it was $390 per ton. Okay, I'm gonna walk you back through this again before we see the final results. This is that soil test recommendation that I just showed you. 55 pounds of nitrogen, 55 pounds of phosphorus, and 10 pounds of potassium is what it's requiring. So the fertilizer dealer, this goes to them on the next section. They're using, but you can plug it in. You can do these calculations yourself. They're using urea 46-0-0, and it's costing $430 a ton. They're using diammonium phosphate for the phosphate. It has 18 units of nitrogen, 46 units of phosphate, and 0 units of potash, and it's $660 a ton. Then this third one that they're using on the blend is the potash. It's 0 units of nitrogen, 0 units of phosphate, and 60 units of potash, $390 per ton. Well, this has been auto-calculating as we go along. So to make this blend per acre, for us to get 55 pounds of nitrogen per acre, it's going to take 119 pounds of urea, costing $25 and some change per acre. For us to get 55 pounds of phosphate per acre, it's going to take 119 pounds of diammonium phosphate, running us $40 to the acre. And for us to get 10 pounds of potash per acre, it's going to take 16 actual pounds per acre of potash, costing us $3.26 per acre, giving us a total application rate of 255 pounds and some change per acre of this fertilizer blend, and it's going to run $68 per acre to put this blend down. So when you get that blend and when you get that printout from the fertilizer dealer, it's not going to say 119 pounds of nitrogen, 119 pounds of phosphate, and 16 pounds of potash. All they're going to tell you is a blend that's going to be numbers much lower than that, and then it's going to have the rate per acre, which will be the 255 pounds, to tell you what setting to set that fertilizer buggy on to get these actuals that we're talking about right here. So how do we get to that blend that the fertilizer dealer hands us? Well, if you enjoy math, you've probably already figured that out. Remember, we were working on 100 pounds or 100% when I showed you a slide a little bit ago that had those three numbers. Those three numbers were 22-22-4. So what we've got to do is divide 255 by 100, which puts us at 2.55. So now we go right back up here to the top on what's our soil test recommended nutrient rates per acre. So we divide, and I'm a person that has to use a calculator, so bear with me here just a minute. My wife is a mathematician, so she would laugh at me right now. But we divide 55 by 2.55, and that gives us 21.5, so we'll round it up to 22. Then again, you know the answer to this one. 55 divided by 2.5 gives us 22 again. And then we do 10 divided by 2.55, and that gives us 3.9, which we round up to 4. So the receipt that you're going to get from the fertilizer dealer is not going to have 55, 55, 10, which is what we would think a lot of times it would have. they're going back down here to this section and they're calculating it out even more. So what they're going to hand you is your blend for that's going in your fertilizer buggy for this particular soil test here is going to be a 22-22-4, and you need to apply 255 pounds to the acre to get that. So that's how we calculate a fertilizer blend based on the soil test recommended nutrient rates. I want to do another one for you. Is everybody with me? Maybe. All right. I'm just going to take that as a yes. We're going to move on to another calculation here. Again, if you have any questions, please let me know. Let me stop the share, and I'm going to go back and I'm going to show you another one. Hold on just a second here. I'll show you a little bit different one that pertains to native grasses. All right, here it comes. All right, zoom in for you here. All right, so this particular soil test is really recent. Just was printed on 3/23 of 2021. So this soil test right here, I actually just got this soil test in this morning, and so I want to use a current one for you. You can see as we get into the different types of grasses how we have different recommended fertilizer rates. This particular grazing or hay is the situation right here. So this person's either going to be grazing or cutting hay on this place, but it's a blue stem, native grass. It's calling for 35 pounds of nitrogen, 35 pounds of P2O5, and 0 pounds of K2O. So we get that wrote down, no limestone requirement there. And we go back to our calculator screen. Give me just 1 second. We'll get this screen shared for you. Sorry to be going back and forth, but just want to make sure. All right, so we reset everything. So this particular soil test calls for 35 pounds of nitrogen, 35 pounds of phosphorus, and 0 pounds of potash. So we're going back. We're using the same fertilizer dealer, 46 pounds to the acre. 430 bucks, or excuse me, 40, we're using urea, so 46-0-0, 430 pounds, or $430 per ton is what it costs. We're using Daemonium Phosphate for our phosphate blend, which is 18 units of nitrogen, 46 units of phosphate, and 0 units of potash. 660 bucks a ton is what that's running us. Then we go down here to our potash, 0 units of nitrogen, 0 units of phosphate, and 60 units of potash, running us 390 bucks per ton. So this particular person here is going to apply an actual 76 pounds of urea, 76 pounds of diammonium phosphate to get 35 pounds of nitrogen and 35 pounds of phosphate. And it's going to cost $41 roughly to apply this at a rate of 152 pounds per acre. So what's the blend going to look like on this? Well, we divide 152 divided by 100, which is going to put us at 1.5. So we go back up, 35 divided by 1.5, that's 23 and some change, so we'll keep it at 23. 35 divided by 1.5, we're at 23 again, and 0. So this particular blend from the fertilizer dealer is going to be 23-23-0 applied at a rate of 152 pounds per acre. And at that rate, we're going to get an actual of 35 pounds of nitrogen and 35 pounds of phosphate to meet the needs of grazing or hay for blue stem on that particular soil for that particular person. So if they're on the, I don't know if they're on the webinar today, but there's the calculation for that property right there. We can do another one if y'all like. I'll be happy to. If not, I've got some more slides to show you. Just feel free. If you want to see another calculation, I'll be happy to do so. Or we can go to some more slides because there's some other things that we need to talk about before before we close out for today. So give me just 1 second here. We're going to share our screen again. Bear with me just 1 second. We're going to present from the current slide here. We'll get this screen shared here in just a minute. All right, here we go. All right, so when to apply fertilizers. For warm season perennials, which is the time that we're starting to think about right now. For fertilizing that ryegrass, it's probably, I'll touch on that before we get into the warm season perennials, but it's probably going to be a few days before we can apply any fertilizer to that ryegrass. So for ryegrass right now, if you are going to be fertilizing that, or any cool season pasture for that matter, especially the annual grasses. Legumes, maybe not so much because they can fix their own nitrogen. But for our cool season annual grasses, we're kind of behind the 8 ball now if we're going to fertilize, but if you'd still like to go ahead and do it, if it fits the budget, probably 40 to 60 pounds of actual nitrogen per acre would be about the max you want to roll at now. So probably urea, if you're going to be putting that down at a rate of 40 to 60 pounds of actual nitrogen per acre would be about what you'd apply. Again, we're really into the point now where that probably should have already been applied, probably back, if you were going to do it, probably back towards the 1st of March, 2nd week of March would have been kind of the cutoff for that. But again, it's one of those things, if it kind of fits the budget and you can make it happen, then by all means. If not, we move into thinking about the warm season perennials. So green up begins when nighttime temperatures are consistently above 60 degrees and the soil temperatures reach 65 degrees at a 4-inch depth. I'll tell you this, I checked the soil temperature at my place this last weekend, and at a 4-inch depth, the soil temperature for last weekend was 57 degrees Fahrenheit. And so we are close. As we know, green up has already occurred. So that tells me that at some point in time here recently, we've been right there around that 60 to 65 degrees. Some of you may have already observed that soil temperature. But, we're right there knocking on the door of fixing to move into a green up, or in some cases, an actively growing state when that soil temperature reaches 65 degrees. That's when we want to apply the fertilizer. When our nighttime temperatures are consistently at 60 degrees, which we've been there, we kind of bounce back away, Looks like we're possibly heading there again. So we are not consistently there yet, but we're close. And then that soil temperature is just right there knocking on the door, that 65 degrees. So this next point here for warm season perennials, and in this case, talking about it, Bermuda grass and Bahia grass, to utilize any fertilizer, it should really be applied after green up when that plant's actively growing. And so what happens many times in our pasture situations specifically, maybe not so much in a hay meadow situation, but in a pasture situation, we've got a lot of volunteer ryegrass coming up right now in a lot of areas. May not exactly be volunteer ryegrass, but we've got some cool season annuals voluntarily coming up. If we go in there and fertilize right now at a green up state on these warm season perennials, a lot of that fertilizer benefit's going to move into those cool season annuals, which only have less than 2 months of utilization left to them. About May 15th, probably going to be our cutoff on them. And then they move into a point, all of them are annuals. And so they're moving into a point of they'll actually die. And so for putting the money where we want to get the benefit out of it, or we use the term investment earlier, we want that fertilizer to be absorbed and utilized by those warm season perennials in a case of what we're talking about right now. And so we want them to be able to fully utilize it, uptake it, and benefit from it. And we're just a little bit away from that just yet. So what's the time frame that we put on that? Well, it all depends on the weather. So the answer is it depends. If we were to point to a date on the calendar, you're probably looking roughly around April 15th when we summarize and conclude what we're talking about on this particular slide right now, roughly about April 15th. Now, with saying that, if we have some cool season annual grasses out there, we want to make sure that we're putting some pressure on them and not letting them get out of control, because taking us back to 2020, with all caution right there, I know a lot of us don't like to look back to that, but going back to our grass growing situation in the spring and moving into the early part of summer in 2020, we had an abundance amount of ryegrass, volunteer ryegrass that come about last year. If we didn't get it cut for hay at the right time, or if we didn't have it properly stocked for livestock at the right time, it got out of hand and it actually set us back on those warm season perennials. And many of you probably noticed, I know I got the call several times up here at the office of, hey, I got all this ryegrass out here and I don't see Bermuda grass anywhere. Well, it's because that ryegrass is shading out that Bermuda grass, Bahia grass, native grasses, whatever the case may be, to keep sunlight from getting down to that soil surface to allow those warm season perennials to move along. So as I say all of that and spend some time on this slide, to allow us to consider the timing of the year and consider our grass of utilization that we're looking at. Probably the most important slide that I will ever show in any slide presentation is right here. Take a picture of it, save it. If you don't take anything else out of this presentation, please take this slide right here. I get the question all the time, nearly every day during the summertime, but we start seeing those, for lack of a better term, we'll call them trash grass. But those unwanted, undesirable grasses that thrive in low or nutrient deficient soils, we'll say. A lot of those grasses are we refer to as maybe we're probably going to call them annual 3-ons. If we're looking at them, but many times we hear them referred to as tickle grass or needle grass or spear grass. Those things, you've all seen them, you've heard of them, you've looked at them. But all of those grasses, they thrive in low nitrogen soils. So what happens right here? How we explain this slide that we're looking at? A lot of people are in a situation in which they're trying to obtain a special appraisal on their taxes. We call it ag exemptions in most terms that we use, but it's a special appraisal. And so anytime we're cutting hay on a place, when we remove that first cutting of hay, we're removing all of the nitrogen that's available. We're removing 14 pounds of phosphate, and we're removing 42 pounds of potash from that soil. The only way we get it back in a hay harvest situation is through applying fertilizer. So every time we take a cutting of hay away, let's just say you put down 60 pounds of nitrogen on this soil, you applied a rate of phosphate and you applied a rate of potash. Well, that you took down, you took all of that 50 pounds of nitrogen away. You took 14 pounds of that phosphate away, and you took 42 pounds of potash away just in that first hay cut. Well, let's say we get some good summer rains and you're moving on to that second hay cutting. Well, number one, there's not any nitrogen available, none whatsoever at all. You're at 0 parts per million. Whatever phosphate's left, you removed an additional 14 pounds of phosphate, and whatever potash is left, you removed an additional 42 pounds of potash from that soil on our second hay cutting. Let's say we get some good fall rains and you get a third hay cutting like last year. Again, there's not any nitrogen available for you to take away. We're still sitting at 0 parts per million. We take an additional 14 pounds of phosphate away, and we take an additional 42 pounds of potash away. So again, we don't go to the calculator on that. So if we get 3 cuttings of hay, we've taken 42 pounds of phosphate total away from that soil last year, and we've taken 126 pounds of potash away from that soil just last year, and we have no nitrogen available. Well, we recommend that you soil test every year in a hay harvest situation. So you pulled your soil test this year, you look at it and you say, holy moly, there's no way I can afford this when nitrogen's running 430, 450 bucks a ton. Phosphate is running near 700 bucks a ton. And potash is near 400 bucks a ton. I can't afford this, but I still got to maintain my ag exemption. Well, we're starting out with 0 pounds of nitrogen, 0 parts per million on the nitrogen. Then that first hay cut, and we're taking these numbers away again. So you can see as we put this into perspective, what happens here. Another thing that comes up, many of you probably do the hay test with us in our hay show. And you've probably noticed in 2 or 3 hay cuttings in a year that if you fertilized initially, that first cut and your crude protein values were probably pretty decent. If you didn't come back and fertilize, like that fine print that I showed you on a soil test a little while ago, if you didn't come back and put that additional 40, 50, 60, 70 pounds of nitrogen after every hay cutting or after every graze down, with cattle in a pasture situation, we get some nitrogen recycling that takes place out of there. So that's why we're not referring to it as much right now on this fertilizer loss that we see. But when that second cutting of hay drops in its crude protein value, and then the third cutting of hay drops again, the reason being is because you didn't come back and didn't put that recommended rate of nitrogen. So crude protein value, if you didn't know, crude protein value on our grass and on our hay correlates with nitrogen. Why? Because the amount of nitrogen in that hay times 6.25 gives us that crude protein value. If there's 0 parts per million on the nitrogen, how in the world can we expect that hay to have any crude protein value to it at all? And so that's how we draw the conclusion on this. And I said, if you don't take anything else away from this presentation, take this slide right here. Take a picture of it, save it, whatever you got to do, and refer to it every year when you take that soil test. The colors of the grass tells us stories of what's going on. Nitrogen deficiency, we're going to have a pale green color. Obviously, we're not going to have any growth. And then as we talked about, low protein. When we're deficient in phosphorus, our poor root system, we don't have the root development we don't have that root system that we would like to see that supports a healthy stand of forage out there and gives us those yield potentials that we're looking for. When we're deficient in potassium, we can have stand loss, yield loss. You've heard me talk about before, and you've heard it in presentations that we've done. Bermuda grass decline. That's one way how it happens is when we get deficient in potassium, we start losing that stand. Again, we talk about paying close attention to the fine print. I'll probably save this for another day because we're just about out of time. But establishing Bermuda grass, if you're going to be doing that this year, and it's going to be another presentation for another day, if you're wanting to sprig, we need to be planning for 2022 if you haven't already started doing the soil prep for that. And if you haven't contacted a person to purchase your sprigs from, because we're right on top of sprigging, moving into sprigging season right now. But seeding, you've got time left for that. We've got a window up until about May the 31st to be able to seed Bermuda grass here. Not as much soil prep goes into that, but for our phosphate and our potassium, our potash, it takes it a little bit longer to amend within that soil. So we would like to get that down pre-plant. Then once we have an emergence and we move into an actively growing state, we come back and top dress with the additional nitrogen that's needed. So why soil test and fertilize? I mean, you saw here's a pasture situation right here on some ryegrass that was planted. You can see the results of the fertilizer right there. You know, able to utilize on some winter calving cows and some calves. So basically, you know, you've got some help there on the ground to help that cow and to help that calf along during an actively growing state. Why soil test and fertilize? I think we stressed it enough just a little bit ago, but you can see what it does in a hay production situation. So we summarize by saying this: don't forget to soil test, soil test, soil test, soil test. And if you haven't done it, it's not too late. Go ahead and get it done. It takes about 2 weeks to get it in. You saw from that one soil test that I showed you that was sent in, just going off of memory here, not looking back at it, I think it was about March the 12th, and results came in on March the 23rd. They're emailed to you. And so that was a 10-day turnaround right there. So it takes about 2 weeks up to get that soil test back. So if you're going to be doing a fertilization on your warm season perennial pastures, you've still got time. So make sure and get that soil test done. How often do you do it? A pasture once every 2 to 3 years. If you're in a hay meadow or a crop situation, you need to be doing it once a year. Basically, if we want our property to do better, our forage to do better, our hay to increase in quality, our pastures to increase in quality, to cut down on the amount of supplementation that we might have to do to those cows. You know, even though with those fertilizer prices, we can still, you know, we could have another presentation on how the numbers work out on this. We can still justify putting fertilizer down. So don't if it fits the budget, don't cut corners on fertilizer because that soil. I've said it many times throughout this year. It's kind of the theme for this year that we're focusing on. But soil is the foundation of your success in agriculture. If you don't focus on the soil, then success won't happen. If we fail to replace nutrients, we lose productivity and potentially lose our forage, and we don't want to do that. There's my contact information. Appreciate you hanging with us on this. I'm going to stop the slideshow. We've got a few minutes for questions that I'd be happy to take if any of you have some here. Had a couple of direct messages. All right. Anybody have any questions? I'll be happy to take any at this point.